Okay, guys, welcome to the 2.6 notes, ratios, rates, and conversions. And today's we're going to go over some pretty simple ratios, basically fractions, just to go over kind of some real world stuff for you guys to help you make smart decisions. So first thing, in red are the three definitions. So a ratio compares two numbers by division. A rate is a ratio that compares quantities in different units. And finally, a conversion factor is a ratio of two equivalent measurements in different units. Okay, so we need to write these three down on our notes, okay, because they will be on a test. So problem one, comparing unit rates. So you are shopping for t-shirts. Which store offers the best deal? Okay, so this is actually very useful in real life, okay, because when you go to a store and you see like a deal like 2 for 1 or whatever, you need to find out what you're actually spending per product, okay. So store A offers $25 for 2 shirts, store B offers $45 for 4 shirts, and store C offers $30 for 3 shirts. Okay, so store A is 25, okay, for 2 shirts. Okay, so when we break that down, $25 for 2 shirts, well, that's going to be $12.5, okay, for 1 shirt. Okay, so this is our ratio, 12.5 over 1. Okay, so that's how much the shirts cost at store 1. At store B, it's $45, okay, for 4 shirts. Okay, and so when we break that down into a fraction and plug that into my calculator, I get $11.25, okay, for 1 shirt. Okay, so clearly store B has a better deal. Okay, and then finally let's look at store C. I have $30, okay, for 3 shirts. Okay, and so when I break that down, that's $10 for 1 shirt. You guys have 5 seconds. So start. So store C is $10 for 1 shirt. So if all these shirts are the same, this is obviously, okay, my best deal. Okay, because it's cheapest, right? Would you rather spend $12.50 per shirt, $11.25 per shirt, or $10 per shirt? Okay, so store C has the best deal. If we go to the next one, got it? If store B lowers its price to $42 for 4 shirts, does the solution to problem 1 change? Okay, so if we plug this in, we have 42 divided by 4. Okay, so I've got $42 over 4 shirts. Okay, so we want to break that down into 1 shirt. Okay, so we're going to divide this. That's going to be $10.50 per 1 shirt. Okay, so once again, I'm just taking 42 divided by 4, and I get $10.50 for 1 shirt. So does my solution change? No. Okay, and it doesn't change because store C still had them for $10 a shirt. Okay, so I mean, maybe I don't know, understand you guys, but I would rather spend $10 a shirt over $10.50 a shirt, if that makes sense. Okay, so store C still has the best deal. Okay. So now problem 2, converting units. What is the given amount converted in a given units? So in problem 2, basically what they're trying to get us is we're trying to see how many hours makes up 330 minutes. Okay, so what we want to do is we want to write 330 right here. Okay, so 330 minutes. Okay, times 1 hour. Okay, and then guys, how many minutes are in an hour? 60. Okay, 60 minutes. Okay, so I've got minutes on top and I've got minutes on bottom, so my minutes cancel. And so basically what I'm doing is I'm taking 330, make a 30 here, divided by 60, okay, to find out how many hours are in 330 minutes. Well, when I do this math, I get 5.5 hours. Okay, 5.5 hours. Okay, so some tough parts with problem 2 is you kind of have to know some things about, first of all, you have to know how many minutes are an hour. Okay, on B, I have 15 kilograms. I want to know how many grams that is. Okay, so I have 15 kilograms. Okay, Well, I know that there is 1,000 grams in each kilogram. Okay, so my kilograms cancel, and I'm left with 15 times 1,000, which gives me 15,000. Okay, 15,000 grams. Okay, once again, we'll spend a lot more time going over problems like this on problem 2 because a lot of you guys don't know that there's 1,000 grams in a kilogram. Okay, most of you should know. Hopefully, there's 60 minutes in an hour, but we'll spend a lot more time going over these in class. Okay, now problem 3. Okay, converting units between systems. So the CN Tower in Toronto, Canada, is about 1,815 foot tall. About how many meters tall is that? Okay, so there's 1 meter is 3.28 feet. Okay, so I start out with, I know that the tower is 1,815 foot tall. Okay, and I'm going to multiply that. Oh, excuse me, let me erase, start over. Okay, so I know the tower is 1,815 feet tall. Okay, times, well, I know that 1 meter is approximately 3.28 feet. Okay, so I have feet on top and feet on the bottom, so my feet cancel. So the only thing left is meters, which is what I want to be in because it's asking me how many meters. Okay, so I have 1,815 divided by 3.28. Okay, and that will give me a final answer of, let me do it because I don't know what that is in my head, 553 meters. Okay, so 553 meters. Okay, so basically, guys, what we're doing again is we're moving from feet to meters. It gives us our conversion right here. So we make a ratio. Okay, our feet cancel, we're left with meters, and it's just a very simple math problem, excuse me. Okay, I want you guys to try the Got It 3A. Okay, and just to make sure you're watching, I'm going to put this big star here, and I want you to star here, and then connect the stars like this. Make it look so pretty. It's like 2 stars like that. Okay, draw that on your page, kind of, just to, once again, see if people are actually watching, just to make you guys mad. Okay, and finally, the last problem we're going to do today is problem 4, converting rates. Okay, so a student ran a 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Okay, so 50-yard dash in 5.8 seconds. So what we want to do, excuse me, okay, is I know that they ran a 50-yard dash. Okay, so 50 yards in 5.8 seconds. Okay, so 50 yards in 5.8 seconds. Okay, I want to know that in miles, okay, and then hours. Okay, so hours. Okay, so we have to do some things here. Okay, first things, I'm in yards, not miles, but I know that for every 1 mile, okay, there is 1,760 yards. Okay, so there's my yards canceling. Okay, and I also want to be in hours. Well, right now I'm in seconds. Well, I know that there's 3,600 seconds per 1 hour. And guys, once again, I don't expect you to know that there's 1,760 yards in a mile. I don't expect you to know there's 3,600 seconds in an hour. I'll give you a sheet of paper that will go over all this, and we will go over how to do. The most important part is we're just building these ratios. Okay, so equals. So guys, we multiply straight across. So I basically get 50 times 3,600. Okay, that's just pathetic. My apologies. Divided by 5.8 times 1,760. Okay, what's going on, mouse? There we go. Okay, so I get a final answer when you plug this into your calculator just like this. Hopefully yours looks a little better than this because this is just borderline pathetic. Okay, you get an answer of 17.6. What is going on, mouse? 17.6 miles per hour. Okay,